Okay, ladies and gentlemen, this next problem, this is 5.1 continues. I've given you a polynomial function. The way you read this function, p of t is equal to 1.875 t squared minus 30t plus 200. Now that function makes no sense unless you know what the variables mean. And as you keep reading, it tells you. This function models an athlete's heart rate in beats per minute t minutes after the exercising has stopped, where t is between 0 and 8. So what that means in English is, we've had somebody exercise. Let's say we're having them do a stress test. At the end of the exercise, we say stop. That's when time 0 kicks in, and we start measuring their heart rate. And we measure that heart rate for the next 8 minutes to see what's happening to their heart rate after the exercising has finished. So t is the number of minutes after the athlete stopped running or jogging or whatever you were having him or her do. P of t, which is the output, think about P, pulse rate. That's why they use P. The heart rate in beats per minute. So part A says, what is the initial heart rate when the athlete stops exercising? Well, what does the word initial mean? If I told you we were in the initial part of an experiment, that would mean time 0. So that key word is telling you to put a 0 in for t. So we're finding P of 0, which to be honest is very easy because anything that has a t in it's going to drop out, leaving me with 200. So by finding P of 0, 200 beats per minute is what the athlete's heart rate is as soon as they stop exercising. You wouldn't want somebody's heart to be beating at 200 beats per minute if they were at rest. Something wouldn't be right there. Okay, part B. What is the rate at the end of 8 minutes? Well, we better hope we get a smaller number. So we're finding P of 8. Now this is the perfect time to use your graphing calculator, scientific. It doesn't matter. Use your calculator. Some of you have a graphing one that makes it a little bit easier. Plug in the number 8. Do your computation, and you come out with the answer 80 beats per minute. Now the reason that should make sense to you, if someone's been exercising, of course they've elevated their heart rate. If everything's working right in their system, their heart rate should be dropping 8 minutes after the exercising has stopped. Okay, part C. If you look at a portion of this graph, the graph of P of t from 0 to 8, is the graph rising or falling? Well, we don't even need to look at the graph to tell. The answer that I have written here is the graph is actually falling. It's going downhill, and that's because you're measuring the heart rate, and the heart rate better be dropping. All right, part D is the weirdest part of this problem. Part D asks you to make a table of P of t starting at 3, and where t is 3, and incrementing by 1. And then the question wants to know, when was the athlete's heart rate between 80 and 110 inclusive? So in other words, you're making a t-table is what you're doing. You know those little XY charts you used to make back in the previous course? We've even made some in here. But this time our input is t, and our output is P of t. They tell me to start with 3 and increment by 1. So that means 3, 4, 5, 6, 7, and 8. We know to stop at 8 because that was the maximum number of minutes we were observing this person. Well, we've already answered that question. If t is 8, P of 8 is 80. We did that up in part B. Let's go back up to the beginning of our chart. At the very beginning of our chart, if I put in the number 3 into my original function, and I use my calculator, I come out with the answer 126.875. If I put in the number 4, I come out with the answer that the heart rate is 110. Okay, we've answered our question because the question said, when was the athlete's heart rate between 80 and 110? Well, it was 110 at time 4 seconds, or actually minutes, and it was 80 at 8 minutes. So what t values in our chart gave us numbers between 80 and 110. Those would be t values between 4 and 8. And you could write it in English. Between 4 and 8 minutes is when the heart rate drops from 110 to 80. Or an algebraic way to write it is using an inequality. 4 is less than or equal to t is less than or equal to 8. And one last comment I have on this problem. When you're putting a quantity into the calculator like this, I personally think you should just put it in using parens. Every scientific calculator and every graphing calculator has left paren and right paren. So what I teach my students to do in a lecture class is put in what you see. I see some students do it so strange. They put little computations on paper and then at the end they add them all together. Let your calculator do all the work for you. Okay, you're going to come across this problem on your Course Compass homework, so make sure that you know how to handle it, and it's certainly a reason to bring your calculator to the test and the final exam.